This is a problem about a small radio transmitter. It says a small radio transmitter broadcasts in a 44-mile radius. If you drive along a straight line from a city 60 miles north of the transmitter to a second city 51 miles east of the transmitter, during how much of the drive will you pick up a signal from the transmitter? First thing you want to do is draw a diagram. So draw our Cartesian axes. Label it. And our transmitter is transmitting in a 44-mile radius. So I'll just choose a red color here and try to draw a circle at the origin where the radius of the circle is 44. So that height there is 44. Now, we drove to a city that's 60 miles north, so we'll just label that 60 here. And we're going to drive to second city 51 miles east. It's here. And our drive should look like a straight line. Excuse me while I correct my circle a little bit. Okay, and there you can see there are 2 points of intersection with the circle. I'll label those 2 points P1 and P2. And those are 2 points of intersection, and this distance, the distance from P1 to P2, that's what we're interested in. That's going to be our x. So x, the unknown, is the distance between P1 and P2. So we're looking for how long that line segment is from P1 to P2. So let's write out a couple of equations here. First, we're going to write the equation of the line. We could simply use y equals mx plus b for that. So b is 60 because that's the y-intercept here. Okay, 0b is the y-intercept, so b is 60. M is the change in y over the change in x. We changed 60 units down, so negative 60, and we changed 51 units to the right. So it's negative 60 divided by 51, x plus 60. Now, you might want to simplify that a little bit. We know they're both divisible by 3. So 51 divided by 3 is 17. So, and obviously, negative 60 divided by 3 is negative 20. So negative 20 over 17, x plus 60. Just simplifying that a little bit. And we know the equation of the circle. It's a circle centered at 0, 0 with a radius of 44. So it looks like a 49, but it's a 44. So we have x squared plus y squared equals 44 squared. Now the idea is we want to substitute this equation in for y and then solve for x using our calculator. So we have x squared plus negative 20 over 17x plus 60, quantity squared, equals 44 squared. This allows us to find the points of intersection, the x values of intersection for P1 and P2. Now we're going to jump to our calculator and calculate approximate values for these x values for these points of intersection. We're going to find x1 and x2, and we're going to just try to use as many decimal places as we can to find those. The other calculator will give us a good approximation. So we're going to click y equals, and we're going to put the left hand side of the equation, that's x squared plus negative 20 over 17 x plus 60 squared, and then in the second equation we're putting 44 squared. Now we may have to adjust our window. We know the x value goes from 0 to 51 as a possibility, so that will give us a good window to look at for our x values, 0 to 51. And the y values has to be at least 44 squared. We can get a great estimate for that by just computing 44 squared. So our y max has to be more than 1936. So we let our y max be 2000. So now we go back to adjust the window, 0 to 51, as we just said, and 0 to 2000 should give us a good viewing window. Click graph. We see 2 points of intersection. So then we click second trace, option 5, which is intersect. Press enter 3 times. So we have x1 is approximately 16.241043, and x2 is second trace, option 5 again. Move your cursor to the right and press enter 3 times. 42.975213. At this point, it is important that we take as many decimals as possible because we don't want to propagate any errors when we make subsequent calculations with x1 and x2, as it's easy to propagate an error with these two x values if we do round at this point. Okay. So now we're going to just find y1 and y2 using one of our equations, and then finally compute the distance between P1 and P2 using the distance formula to complete our problem. So let's go ahead and find y1 and y2. So y1 is going to be approximately negative 20 over 7, and then we're inputting 16.241043 plus 60, and y2 is almost the same thing except we replace 16 x1 with x2, which is 42.975213 plus 60. Again, we're going to use your calculator to calculate what these values are. You will not do this by hand. So let's calculate what these are. So y1 is approximately 40.89289059, and y2 we do the same calculation except we replace 16, which is x1 with x2. It's 42.975213 plus 60 is approximately 9.4409258882. And again, I take as many decimal places as possible, only because we don't want to propagate any unnecessary errors in our final calculation. So now we're going to insert a blank page, running out of room in this page, and we're going to use our distance formula to compute the distance between P1 and P2. So let's do that. So remember, our distance at the beginning we called x. So x is going to be equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. This is the distance formula. So we're going to just use your calculator to compute this. We're going to use the difference between x2 and x1 and the difference between y2 and y1. Square each of those quantities, add them, and then take the square root. So let's do that over here in our calculator. So second square root, parenthesis, x2, just enter that in, minus x1, quantity squared, minus, sorry, that's a plus, parenthesis, y2 minus y1. Fortunately, we have y2 here, minus y1, it's here, quantity squared, and what do we get? We get that x, which is the distance from P1 to P2, is approximately 41.27883.149 miles. In this problem, they didn't want us to round any, but typically you look out for any rounding that they would want in the problem, and you would round appropriately. Thank you for watching.